Today we are looking at Leetcode problem number 3443, maximum Manhattan distance after k changes. In this problem, we are given a string S, and S of I represents one of the four directions that you can take, and you move in this direction by 1 unit. You're starting from the origin, and you have to move in the directions given in the string, but you're also provided with an integer value k, which you can use to swap these integer directions based with another direction, and what you are expected to return is maximum Manhattan distance. So the Manhattan distance for 2 points, let's say point 1, which is x1, y1, and point 2, which is x2, y2, can be given as the difference in the x values plus the difference in the y values. So let's say if this is the origin, and let's say this is P1 and this is P2, and let's say P2 is at a distance of 1 and P1 is at a distance of 2, then what we're seeing is that the x difference is 2 minus 1, and same way let's make them as 2. The y difference is also 2 minus 1, and so what we get is 1 plus 1 as 2, which is the total Manhattan distance. In another way, you can think of it like this. So you need to move one direction in x and one direction in y to get from P2 to P1 or from P1 to P2. Okay, so now this is what is given to us, and now we need to identify the maximum possible Manhattan distance that we can get with k changes. So before we get into the problem, let's think about the intuition. Okay, when would you want to make a switch? Okay, let's think about it. Let's say your S is N and S, which means you go north from the origin, and then from this point you come back, and then you're back to this origin. So the Manhattan distance from origin is actually 0 because you're back to the same point. So what happened here? You moved in one direction and you moved in the opposite direction, so this canceled each other. What we want to do is reduce the cancellation effect that happens and have more of the additive effects that happen. That means we want more of NN or we want more of SS. Okay. What about NE? This is good because from here you go north, and then from there you go east. Alright. So what's the distance? The overall distance is 1 plus 1, 2. So now if we take this on a much larger scale, what we're saying is that, let's say from the origin we go up, apologies for this. So let's say we go up, and then we go east, and then we go again up, and then we go west. This had a cancellation effect on this, and then we go up, and then we come down. So we come down, this had a cancellation effect on this, and so on. And so what we want to do is, if you're moving in one direction, you want to add more power to this or add more value to this, as compared to if we are moving slightly in the opposite direction. We want to take this. To make this happen, we want to find the maximum in y direction and the minimum. So this is the maximum and this is the minimum. And what we want to do is, if the minimum is allowed to be adjusted, I want to take this and put it here. Same way for the x-axis. Okay, let's say this is the origin. I want to find the maximum. And then I also want to look at the minimum that I have in the opposite direction. And if my k allows, I want to take this and I want to put it to the maximum side. Okay, and what we only care about in this problem is the overall Manhattan distance. Okay, that's all we care about. We don't care about the actual course that you took. Okay, so the way that we're going to deal with this is just think about the maximum and the minimums. So let's say I have an array, okay, with 4 values. And let's say this represents north, south, east, west. Given a string of some characters, I will like to build this one by one. Let's say I had the first one as north. So I say north is this direction has been counted once. And then what I will do is I will find the directions in both the sides. So in x direction, we have, let's say, 0, 0, 0. So in x, what is the minimum that we have? Minimum x, I have 0. What about the maximum x? I have 0. East, west, right? So this goes east, this goes west. So we can say this is the x-axis. Okay. What about the y-axis? Okay. The min that I see is 0. The max that I see is 1. Okay. Let's progress a little bit more. Let's say we had north as 3 and then maybe south as 1. What happens then? My max becomes 3 and my min becomes 1. And now what I want to do is adjust this min. Adjust this min to the max because I want to increase the max and reduce the min in order for me to get the maximum Manhattan distance. Okay, so that's what I'm going to do. What I'm going to do is find how much can I adjust. Okay, so I'm going to find a delta, which is going to be the minimum of the current k capacity that it holds and the current minimum. Okay, let's say my k was 2. So I'm saying min of 2, 1. So I can take this 1 and what I can do is subtract it from the min, which gives me 1 minus 1, 0, and add it to the max. So max plus 1, which is equal to 3 plus 1 equals to 4. And now what we are saying is that after one iteration of this, I'm going to look for the best distance seen so far, which is equal to the max of best distance, comma, the max minus min. Why max minus min? Because I had some y, let's say, and this was, let's say, 2 units, and I was able to, let's say, accommodate only 1 unit. So this went from here to here, but there is a little bit still left because my k did not have the capacity. K was lesser than the minimum that I had. So then I take this much max, which is good taking me forward, and I still have a negative pull down effect coming from this minimum. So I do this. Okay. Now this run through I've done only for y. We gotta do it for both x and y. So how does all of this change? What we try to do is for each we find the min, the max, the min, the max. Okay, and then what do? We say on the y-axis this is the max, on x-axis this is the max. Overall, this is the total amount of the maximum direction that we're getting, and there is a little bit of minimum coming from these directions. Okay, so we have that max, we have this min, and so we total this up. Okay, and we say my delta capacity is minimum of k minus total minimum. Maybe I was able to adjust this, or maybe I was and not able to adjust this, or it was the other way. All of that, the actual order of which direction it moved is not really important. So all we care about is the counting and the adjustment. So what we do is from this total plus this total, we just subtract this, or rather we add this to this total. Let me make it like this. So we had the y max, and then we have the x max, and then let's say we added this plus we added x min. So from this total, because this got adjusted thanks to our k, otherwise it would have gotten subtracted. So from this total, now I'm left with just subtracting this negative effect minus y min. So you do this, and this is your new Manhattan distance. How is that the new Manhattan distance? You will see that it will go something like this and like this. And so Manhattan distance is nothing but the sum of the delta x and the sum of the delta y. Okay, so that is for this problem. Let's move into writing the pseudocode for this. Okay, I am also going to follow another very interesting trick that I've learned recently from Larry's videos, which is instead of using max and min, you can write lambda functions. Okay, let me show you. Let's say f min is equal to lambda x comma y gives you x if x is lesser than y, else returns y. Same way, f of max is equal to lambda x comma y gives you x if x is greater than y, else returns y. Now these are much faster than your traditional min and max, because min and max has a little bit of an overhead. It needs to identify what is the input type, and because it can handle so many different input types, you can either send an array or you can send two values, right? Because of that, it becomes a little bit slower. So if we use this, it gives us additional boost in terms of the performance. Yes. So what I was saying is that we get additional boost when we use these fmin and fmax, but these are not algorithmic boosts. So it just pushes your runtime a little bit faster, but it's not algorithmically faster. Okay, so let's still use them, and let's have a direction string north, south, east, west, and let's have a counter array which will keep the count of our directions. Let's start with the best distance. We want the maximum, so we start with a negative, very low negative value, and so we say for ch in s, okay, you pick the index of the ch. Index is equal to direction dot index of ch, and then what you do is you increment your counter, and now you evaluate the advantage or disadvantage that you're getting by taking this index. Okay, so let's start with finding the total min and total max. Okay, so total min is nothing but f min in the two directions taken separately. So if we look at the directions, we have north south first, which is the y direction, and then we have on the x direction. So we can say counter of 0 comma counter of 1 plus f min of counter of 2 comma counter of 3. So this is the total min that we are taking in both of these directions. Now same thing for the total max. So total max is equal to F max of counter 0, counter 1, counter 2, and counter 3. Once you have identified the total min and the max, now is the time to compute the delta. So delta is equal to F min. How much can our K help us switch? So